So welcome all. Today we are going to learn something about IP version 6. Okay. So the first question is actually why we are going to see this IP version 6. There must be some limitation of IP version 4. What is it? Actually, with the 32 bits of IP version 4, we are going to have deficiency of IP version 4. Okay, we will have less number of IP addresses to assign all the possible equipments that we will have, right? Starting from the stationary computers to the mobile equipments. Okay, now in the coming days we want to have a smaller, I should say, we will try to perform ubiquitous computing for smaller machines as well, right? We will try to assign such addresses to them so that they will be able to communicate and have exchange data, right? So for that purpose we will this IP version 4 will is deficient. Okay, so now address space is less. Then new types of services like integration, multicast, quality of service, security, and mobility. These are few things that we want to implement, and there are certain limitations in IP version 4. We can find about header and footer format of the packet. So then we are going towards IP version 6, where we will have a larger address space. Okay, here we will have a larger address space, since we will have 128 bits for address. So that is I should say much more than earlier. Earlier it was only 32 bits, so we were having just 2 to the power 32 addresses. Now we will have 2 to the power 128, so it is somehow 2 to the power 96 times more than that particular range, right? Better header formats, like now here in IP version 6 it uses new header formats. Okay, so in which you will have options. Okay, so these options are actually separate from the base header. You will have a base header of a particular size, and there are optional headers. Okay, so when needed between the base header and the upper layer data, we can insert it. So this simplifies and speeds up the routing process, because most of the options do not need to be checked by the routers. Okay, now some new options have been added. We will see those additional functionalities that we have. Allowance for extension. IP version 6 is actually designed to allow the extension of the protocol. New technology or applications can always be supported. Resource allocation can be supported. Suppose in this IP version 6 the type of service field is there, right? Means type of service field was in IP version 4, which has been removed now. But here two new fields, like it will be traffic class and flow label you will have. These two have been added, right? It enables the source to request a specific handling of the packet, right? So this mechanism can be used to support traffic such as real-time audio or video transmission kind of thing. Okay, so it actually fixes the resources, and also you will see it can be considered as connection oriented. However, earlier The IP version 4 was not like that. Okay, it supports mobility and it is more secure. You will see it has some features of authentication which was not there in IP version 4. So now, till now you are not using this IP version 6 in your computers. Why? What happened? Why actually this? When we realize that IP version 4s are going to not be available anymore, what happened that this is delayed? We are delaying the use of IP version 6, right? So actually what happened, we got to have certain options, right? Short-term remedies we have got. We can call it, it was, you should say, the classless addressing, okay? Use of DHCP protocol, which allocates the address whenever the system boots, right? Okay. Now the other thing was address translation kind of things was introduced, network address translation. So such things can actually help us right now to handle the devices currently we are having. But anyway, in future we are going to have lot of devices which are capable of moving from one place, which it will have mobility. So they will need mobile IP, you will have IP telephony and mobile telephony and other several things where you will need different many more addresses, right? So now we will need this IP version 6. So the next thing that you have to see is the packet format. So actually here you have to understand that this IP version 6 packet you have here in your next figure here. So basically here what we are saying that each packet is composed of a mandatory base header, okay, which is of 40 bytes, and the additional payload, which is definitely of 65,000, means up to 65,535 bytes. Okay, so this is some information about it. Within this you can have some extension headers as well. Base header is 40 bytes, it is fixed. However, after this base header you can have extension headers also. You will see how these extension headers can be used. Each header you will have a length field. It will tell you the length of the option header, and you can use as much option headers, and then the payload, whatever the data is. Okay, so you know that in IP version 4 this was the packet format, right? Version, length, type of service, and like this. Now in IP version 6 some of these have been removed. That is the header, length, type of service, identification. These fields have been removed. However, you can see source address and destination address are still there. However, it is not of 32-bit, it is of 128 bits, right? Now version is still here, no problem. Now removing this these two and this 3, okay, and apart from these, whatever has been remaining here, you can see they have been actually modified. So now let me tell you about this. What happens here, you can see version is still here, version 4-bit, which is it will define the version number, right? So the value will be 6 here. It is, now you can see it is traffic class and flow level. So what happens in traffic class, another 8-bit, it will actually distinguish between I should say different payloads, right, with different delivery requirements. So earlier you were having service class, service type, so now you are having traffic class. That is the thing. Flow label is something which is near here. It is here 20-bit field. Now this is designed to provide a special handling of a particular flow of data. Okay. So if the name has come, we can see actually what it does. So you know that when IP was designed, in that protocol actually it was connection-less protocol. So now when this we are having a flow label, so it will now tell you how to have a connection-oriented protocol. Okay. So see, to a router, a flow is a sequence of packet. Flow is a sequence of packet. Okay. These sequence of packet, they share some characteristic such as traveling the same path, using the same resources, having the same kind of security and other features. Okay. So it is also true that some routers may support and some routers may not support this flow labels. So a router that supports the handling of flow labels has a flow label table. So this table has an entry for each active flow label. Now this each entry defines the services required by the corresponding flow label. When the router receives a packet, it consults its flow label table to find the corresponding entry of the flow label. So according to the packet, it then provides the packet with the all the services mentioned in the entry, whatever the entry was there for the particular flow label, right? Suppose this flow label itself does not provide the information of the entries of the flow label table. Then what will happen? The information is provided by other means such as the hop by hop options or other protocols we have here. You will see additional options we add here. So now you can understand this flow label can be used to speed up the processing of packet by a router. When a router receives a packet, instead of consulting the routing table and going through the routing algorithm to define the address for the next hop, it can easily look up in a flow label table, right, for the next hop. So this is use of this flow label. Then you have this payload length. You know that payload length is actually this 2 byte, right? So it will define the length of the IP datagram. It will not cover the base header, excluding base header. Okay. Then this is next header. Okay, next header. You're actually you were having a protocol there, right? It was telling you about which protocol it is being used, right? So this next header is actually something here which will tell you what is here in after this header. After this header you may have certain more information. It may be of option fields and other. You will see in next slide that how next header field is telling you about, we have certain information here, right? So basically here I can tell you that next header is either one of the optional extension header used by this IP, or the header of an encapsulated packet. Maybe the packet will be UDP, or it can be I should say ICMP. Okay, ICMP, TCP, UDP. Yeah. Such packets can be encapsulated here, as well as certain option fields can be here. So it will tell you that what is the next header here, right? So it will tell you that this next header. So it will actually have a value, maybe 0 to 6, 17, 50, 51 kind of. You will see the values and meaning. Hop limit is same, the time to live you were having there in the IP version 4. So it has the hop count, how many routers it can pass. Source address and destination address you can understand. Now it is of 16 bytes each. If I tell you about this codes of the next header, you can see it is 0 for hop by hop option. Options are some there. You will see ICMP, UDP, TCP, source routing, and these kind of these are another extensions. So these extensions, if at all they are there, these are optionals actually, option. So these all are optional. They can be present or they may not be. So, but base header is something which is fixed 40 bytes. It has to be there, and after that these can be there, these may not be there. So accordingly, a particular code should be written in the next header field. Now, this is the next header. You can understand what is happening. So if you have this next header, and in this next header you will have the address of this thing, right? Okay. Now the thing is, you can have up to 6, I think, yeah, up to 6 types of extension headers. Okay. Now, actually in IP version 4 also you were having options. So many of the options are from there only. Now here you would have seen that we don't have a fragmentation field. So here this fragmentation has been kept in extension header means options only. Okay. So it will tell you next header, about the next header, and again you will have the next header option, and so on. It will tell you that yeah, next header is also there, more options are also there, so on. You have seen here, right? So now these are the extension headers possible. It can be hop by hop, it can be destination, source routing, fragmentation, authentication, and encapsulated. SP is actually encapsulated security payload. Okay. So you will see these things now. So hop by hop option header. Definitely next header, header length, and option, right? So is there something that we have to understand here? Yeah, one thing is hop by hop option header, why it is being used, right? So it is used when the source need to pass information to all the routers visited by this particular datagram. You can have information related that what are the systems, what are the routers we are going to pass through. You can have the information related to certain management, maybe debugging or control functions. Such kind of information can also be kept here in hop by hop, that these are the information which are given to all the routers. Suppose in some cases if the datagram size is more than something, it was defined 65,535. So if it is more than that, then in that case router must be informed, right? So that is the way. In this way, this is the option header format. So here the first field, you can see it is the header in the chain of header, right? So then it is header length. It defines the number of byte in this header. Also this header length includes the next header field. And now these are the different options in whatever. So suppose you have this thing options here. In detail you can see in this option you can have code. This code will be having 3 parts: 2-bit, 1-bit and 5-bit. So this 2-bit will tell you that you have to skip this option or discard the datagram, no mode action, send ICMP message or send ICMP message if not multicast. This 1-bit will tell you about whether the padding, it tells you about whether does not change in transit or may change in transit. Okay. Then it is type. Here it says that padding is there, right? So whether it is pad 1, pad n or jumbo payload. Okay. So maybe in next slide we have this thing. It is just saying about what can be padded in last. In pad 1 it is just 1 byte. Just the code will be 000. So whenever the option was just 1 byte small, in that case you will pad 1. If at all you have more than 2 or more than 2 byte, in that case you will have like this: code will be 0001 and you will specify the length and all zeros. Okay. Jumbo payload can also be there, where you will specify the code as like this: 00010 and the length and then whatever the payloads. Then we are going towards another option. Source routing. So here you can understand, actually this source routing extension header combines the concept of a strict root source root and the loose source root options of the IP version 4, where we were specifying the particular route that you have to pass through these routers. So these are this is the source routing option, which is telling us about the source routing. These are the addresses of the routers through which you have to pass. So next header and header length, you understand. Here you have type field. This type field actually defines loose or strict. Loose or strict. Then addresses left. This field will indicate the number of hops. Number of hops. After that you have this thing, okay, reserved field, and this thing is strict loose mask. Okay, strict loose mask field actually determines the I should say rigidity of routing. If it is set to strict, in that case routing must follow exactly as indicated by the source. If instead the mask is loose, in that case what will happen? If the mask is loose, then suppose in between you can visit other routers also. Means whatever is mentioned here, you will have to visit, and other than that you can visit other also. However, if the mask is also strict, in that case you will have to visit these routers only. That is the thing. So now it is the source routing example. Okay, so suppose this was the format, source and destination is giving, and left 3, in the last field here number of hops left, so we have given here it is 3 left, so you have to visit R2, R3 and B. So here you are at R1, now 2 left, you are at R2, 3 left, and then you are at R3. Okay, so this is how it will work. Then it is fragmentation. What happens? The fragmentation is similar, you understand, you were having earlier also fragmentation, this identification, then flag bits, and then fragmentation offset. So here also you are having this information. However, it is little different from earlier, that it is not earlier in IP version 4. What was happening? It was fragmented in IP version 4. What happened? It was fragmented at all the source or in between routers, right? But in IP version 6 it is fragmented at source only. So what happens, this source will have to use something called path MTU discovery technique. It is called path maximum transmission unit discovery technique. So using this technique, it will find out the lowest MTU of a particular the path, and that minimum size will be that then this fragmentation will be of size that particular minimum size only. Okay, you already know this offset means the particular part of the fragment identification, which will be same for all the fragments. You also understand this M bit. Then we have authentication. This authentication extension header actually it has I should say 2 purposes, right? It actually validates the message, I should say the sender also, and also ensures the data integrity of the data, right? So these are the 2 purposes for which this authentication will be used. So here in this format you can understand, here you have a security parameter index. This defines the I should say algorithm used for authentication, and the authentication data field, it will contain actual data, generated by that particular algorithm. So now we will see something called, if you want to calculate, there will be certain algorithm, and you will have this IP datagram. This authentication field may be kept as 0. You will keep the secret key in this algorithm and you will get the authentication data. You can match this authentication data with the authentication data. Is it matching? If at all it is matching, it is okay. So that is very simple thing, how it works. You have to know something about encrypted security payload. So it is another extension, right? So it provides confidentiality and actually guards against eavesdropping. So data is encrypted here, right? Security parameter index is here. So both the thing is same. So now the thing is this 32-bit security parameter index actually will define the type of encryption or decryption used, right? Type of encryption. Encryption or decryption, whatever. So now this field contains the encrypted data along with any extra parameters needed for the algorithm, what kind of things, right? This actually encryption can be implemented in two ways, either in transport mode or tunnel mode. So in security we may study something about this, about how this encryption, decryption are done in transport mode or tunnel mode. So these are few things that we have seen here in this thing about all the different kind of extensions. So now we have understood about the packet format of IP version 6. However, if we are using IP version 4 and IP version 6 both on the internet, then how we will transform our data, I should say the packet, from one version to another version, how it will work. So basically here you will have three different techniques actually. We will have a dual stack, tunneling and header translation. Let me tell you about these three strategies. In dual stack, that we are saying that all the softwares, all the computers dealing with this IP TCP IP stack, they will have a stack where both the options they will have, IP version 4 also, IP version 6 also. So suppose on a particular router, in this side you have systems related to IP version 4, means it is connected to two different systems with IP version 4 and IP version 6. So as it is handling with the IP version 6, it can encounter and process it according to the IP version 6 software module, and IP version, where it encounters IP version 4, it can work according to IP version 4 module, right? So this is the dual stack thing. Now the other thing is tunneling strategy, where you have IP version 6 host and you want to send this data to another IP version 6 host, but there is certain region in between where it is IP version 4 region. So you will have a tunnel kind of thing, where you will actually have the payload, your IP version 6 header payload. You will just wrap it into I should say IP version 4 header, and you will transmit to those till that particular region where it is IP version 4 only, and when it will come to IP version 6 region, again you can remove that particular IP version 4 header, and IP version 6 header will continue. In this way it will work. Another strategy is header translation. Actually, in this case what will happen, the header will be translated. Actually, earlier it was encapsulated within another header. Now what will happen in this case, you will have this IP version 6 header and payload is there, right? So there will be a router which will understand it is IP version 6. It will convert totally, it will take the payload and attach a new header, IP version 4 header, and transmit it to the new host. So this is a strategy which can be used. So these are the three strategies for this particular translation of IP version 4, IP version 6, and related to as it is needed, right? So these are the things that you have learned about IP version 6. So thank you.